Welcome back to Aquatics Live YouTube channel. Please like and subscribe and hit the notification bell and all that jazz. Hey guys, I have a little update here. So it's kind of a little bit of negative thing happened here, but I'm making a positive out of this and making an upgrade to the system here. My choice of wiring these up using this little logic level converter. Yes, this did work for doing the motor speed on it, and but I did have some issues with the direction and braking on it, and I hadn't run it like full speed yet. Well, I went ahead and I wanted to do a test on it and just kind of go full speed and like apply the brakes like an emergency. And what happened there was it ended up sending a shock back, some kind of pulse back to the system, and blew out the 5-volt power supply, and also blew up my new GPS that I had. So this is trash now. The component that blew up is underneath this little metal shield. I'm not sure if it's something I can fix, but I'll look at it in the future. But it's not too expensive, but it did kind of put me back. You know, I'm a little, you know, I'm pretty bummed about it. But then after I thought about it, I knew there's got to be a better way to do this, a little bit more isolated from the system. So I did some searching and found another module out there that's a much bigger, beefier module. So, and I decided I'm going to run 4 of them separate. So what I was going to do was I had them all running through like one I/O interface. Now I'm going to run, each motor has its own interface isolator for it. So there's an optocoupler piece to it, which essentially it shines a light across and sends the signal over, so there's no way for information to get back, which is essentially how this little guy worked here too. But the problem I had on here is my power and grounds on here were coming from the same source as the power and ground for the little microcontroller board, and that must have been where I had the problem. It probably, I guess it somehow sent back a shock on one of those power wires. So anyway, so it's the introduction of of what I'm going to use for this. So I'm going to bring that over here. We'll get you moved over, and we'll see this here. See the little board. So all right, let's kind of rotate you around, and I got it all kind of like hooked up together here, so you have to bear with me. But and I'll show you a like zoomed in picture of this little guy here. And this is my this is the ESP32 that I'm using for the testing and stuff. The same one I've been doing all along. I did replace this as a new one when that shock happened. I didn't feel confident in that previous one, and it's so they're only like $4 or $5, so it's not worth trying to mix in a possibly bad one into the system here. Okay, so we have our boards here, and then here's the driver. Let me get this motor in shot here. I think you can see it over here. So here's our motor, and so we got everything here. I'll bring in my chair here. So yeah, this is this part of the deal. And I just wired in, I'm using the program that we did before with the pulse pins, and just doing 4 outputs on here, or I'm 3 outputs, and then I have a ground wire running across, and then on this end I have the grounds jumpered together, and then I have my outputs over here. So let me show you the next piece to this is the one down side of this little board here is that it uses MOSFETs, which is good. You know, they're much higher power. They can do 10 amps, which is, you know, that's much better. But the problem with MOSFETs on this particular board is that they're all common positive, and it's switching the negatives. Well, and this little guy over here is looking for positive signals. So what I did is I have put some pull-up resistors on the 3 outputs on here. So when there's no signal going to this, these wires are outputting a positive signal to here. And what that does also on this end is, so when it's failing, the brakes are applied in the system, which is good. This keeps it resistance on here, and so the cart won't be rolling around on its own when the power's off, and we can probably set up like a bypass switch or something like that, so we can move it around without any resistance. But I'll figure that out later, essentially. So, but that was a kind of a negative to this, and that's why I didn't want to go with it at first. But I did think of a way around that by using these pull-up resistors, and then the logic behind it, behind that is that I have to work around that everything's kind of upside down, you know. So this is kind of like a little setup I printed out, like the first page of my Arduino Pulse thing. But anyway, I've just got the pins all wired in here and setting up my outputs. But I did this mostly just to explain the program that I got in here. The way it starts up is we're applying motor off, which happens to be like turning it on. So we go to 255, and then I'm also releasing the brake. That's 255. So, or you know, so it's sending. That's on Arduino. It's like their range for its PWM outputs is 0 to 255, and 255 is like completely on. So these are both on as far as that goes, which ends up turning them off because everything's opposite. So we got motor off, brake off. Now we're going to turn motor on by taking that down to 200, and that's very low speed. And then we're working our way down to 0, which is full speed, and then work our way back up to 200 here. And then I'm sending out a PWM signal of 0 to the brake, and that applies the brake and locks it up, you know, stops it. Then like in real life, that would be how I would want to change the directions. I'd go down to 0, you know, I'd take the motor speed down and apply the brake, change directions, and then I'll release the motors and start working my speed back up. I'm doing all this very slow in this process, but you know, in real life this would happen. You're moving ahead and you slow down and you stop. It'll all happen instantaneously, but in fact the program that I have kind of set up for the long range deal is it kind of decreases the speed by 1 digit at a time every time it rotates through the loop. But it happens extremely fast, so it just like ramps down and ramps up, but it goes much smoother that way. But then at the end of that, you want to apply the brakes before you change directions. I found that if you don't do that, even if the wheel isn't spinning and you don't have the brake applied when you change directions, the motor clicks a bit and kind of makes a little weird sound. But if you have the brake on when you change directions, it's nice and smooth. So just kind of working around. I don't know if that click noise would be a problem, but I figured, hey, let's try to fix this so it doesn't become a problem. And that's what I'm running around over here. I'm gonna bring you back up here to look at this this screen over here.
Real close. So we'll see how good we can get on this. If you can see it on here, and if it doesn't come up through there, I will put an image up here to kind of show this. So I'm gonna plug in the I got the USB cable for that Arduino over here. I'm gonna just plug that in to get some power to it, and that'll start my little sequence up. It has a 10-second startup time in there, so we get some time. And then what we're going to be looking at is that PWM signal in here. It's going to be dropping this down. See, it drops down, and now we're getting signal. And you can see that on the screen here. You can see the pulse width modulating bigger and smaller. So now I'll just bring you over to the motor now. Bring you down here so we can get closer in on the motor, and then you can see this all in action here. And get you so you can see this board, the lights on there. You can see the kind of logic happening. So it's pretty cool. And then it locks up the brake, and it's nice and hard to turn. And then it's going to release the brake when it starts the program any second now. There it goes, releases it. Nope, then it starts off. Bing, bang, bing. Now it's going to go down, hit the brakes at the end, change directions. And now we're going that way. There we go. No clicking, no noise, nice and smooth. Just the way we want it. So we kind of made a switch swap over here, and I'm happy to make some progress. And I know it was kind of a kind of a negative that I lost out on the, messed up on the first one. But I think these little driver boards, I'm going to use 4 of them. It's kind of big, but they're going to be much more stable in the long run, and I have more features to be able to use that. There's a 4th channel, so I only need 3 channels for the motors right now. But there's a 4th open, and I could use that somewhere in the system. So maybe lights or some, I'm kind of thinking about, doing like, hey, want little headlights or something, or maybe a light for each wheel, and then you know what direction it's going. I don't know. It's, future, kind of leave some room for upgrades. So anyway, well, hopefully I can get this all back together. I had to order these boards. I did get this one from Amazon here, this one I'm running, but it's pretty dang, it's expensive getting it directly from, getting it through Amazon versus just ordering it from like AliExpress, which they're $2 a piece on AliExpress. And I think I spent like $15 for this one board here. So now I can get a whole pile of them and get these installed. Now long range though,
I've been looking at this board under my little microscope deal, checking out how it's all wired up, and it's a pretty simple little system. So I think what I might do is when I'm all done with this, I'm going to build a board to have in the deal that's got all the drivers on it and the ESP32 already on that board, so it has all the drivers and so it's set up to do 12 channels, 4 channels per wheel, and just rock solid kind of setup. And if somebody else wants something like that down the road, then maybe they want, we'll see how it goes, but I'll put them up on, I'll make like a set of 5, because you can get a 5-pack from the JLC PCB, and I'll try to pop up the other ones and see if somebody else wants those or not. But if not, I'll have some spares. So you never know though, because sometimes some stuff I've made, I've sold quite a few items on them, and then other things I thought for sure would sell, not a single one sells. So you never know. So, well, thanks guys. I'll see you hopefully soon with this thing actually driving around, much more solid than our original little test drives. So thanks.